Welcome to the Explainer. So, have you ever hit a massive brick wall when trying to learn something complex? Just feeling completely frustrated and stuck? We have all been there. But today, we're going to crack the code on how to overcome those academic frustrations and master complex subjects faster than ever. We're stepping into the shoes of a learning detective to uncover the absolute best secrets of accelerated learning.
Here's our roadmap for today. First, we'll define accelerated learning. Second, we'll look at a really cool success story from CMU. Third, we'll figure out how to become a learning detective. And finally, we'll build up your accelerated learning toolkit.
All right, Section 1, Defining Accelerated Learning and How We're Shifting the Educational Paradigm.
Okay, let's dive right into this. When we talk about accelerated learning, we're basically looking at a highly effective pedagogical approach. It's all about prioritizing your exposure to grade-level content, getting you right into the good stuff. But, and this is absolutely crucial, it pairs that with targeted, timely support for prerequisite skills. It's not just tossing you into the deep end without a life vest. Rather, it's tossing you a flotation device exactly when you start sinking.
Think about traditional learning methods for a second. They usually rely super heavily on extensive remediation. Getting pulled back endlessly to review the basics. Honestly, it just creates this frustrating learning wall where your motivation completely drops. But with accelerated learning, you keep moving forward. You tackle that grade-level content, and you surgically patch up your knowledge gaps the very second they pop up. It's just a completely different, way more empowering vibe.
Moving on to Section 2, the CMU success story, a data-driven proof of concept.
To see how powerful this actually is in practice, let's zoom in from that broad definition and look at some high-level institutional success. Carnegie Mellon University really wanted to test this accelerated learning idea on their statistics students. So what did they do? They utilized a data-driven online tutor combined with real-time instructor dashboards. Instead of just lecturing and waiting for a midterm exam to see who was falling behind, they used tech to track student progress continuously. They were hunting for those exact moments where prerequisite skill was missing.
And the results of this study? Totally validating. Researchers found that this approach significantly improved student outcomes in statistics through immediate, personalized feedback. That right there, immediate, personalized feedback, that is the engine driving accelerated student outcomes. You aren't waiting weeks to find out what you did wrong on a test. You fix the gap the very second it appears. All right, Section 3, Become a Learning Detective. We're talking about the feedback and iteration log.
So how do we take this fancy institutional data and actually apply it to our daily lives? Well, meet Captain Spark. Captain Spark is a persona who treats learning like an active investigation, using something called a feedback and iteration log. This log literally helps you look at your learning like a scientist by continuously monitoring and adjusting for impact. The whole goal here is to gain a much greater awareness of your own educational journey. It forces you to stop flying blind and start actively measuring what is actually working for your brain and what isn't.
Imagine Captain Spark is running through some math flashcards for multiplication. Before he even flips the very first card, he logs a prediction. Let's say the predicted score is an 8 out of 10. But then he takes the practice run and the actual score is a 6. Okay, see that gap between the 8 and the 6? That right there is the exact space where accelerated learning needs to happen. It's the gap between what you thought you knew and what you actually know.
Which brings us to the super simple 3-step flow of the feedback log. Step 1, make a prediction, just like guessing the 8 out of 10. Step 2, see the result, which was our 6 out of 10. And Step 3, calibrate. Honestly, calibration is where the real magic happens. This is where you pull out your metaphorical magnifying glass and figure out exactly why things happen the way they did and how you're going to improve for the next round.
Let's look at a real example of calibration straight from the log. My model was wrong because I confused my 6s and 7s. Next time, I will make special flashcards. Do you see how incredibly powerful that is? You aren't just sitting there saying, "Ugh, I'm bad at math," or "I failed." No way. You've isolated the exact tiny error, confusing the 6s and 7s, and created a very clear, actionable plan to fix that precise skill immediately. You literally turn a failure into a roadmap. And this brilliantly illustrates why the log is so vital. It basically acts as a customized plan for everyone, totally regardless of your current learning speed. For frustrated students, it helps them see exactly why they're stuck and gives them a tangible plan to persist through the difficulty. On the flip side, for fast learners, it helps them fine-tune their study strategies for even more efficiency. You act as your own private tutor. Which brings us to Section 4, your accelerated learning toolkit. Let's execute that calibration phase.
Okay, so once you log your errors in your detective notepad, how do you actually fix them? Well, there are 3 fantastic evidence-based tools that optimize your learning efficiency and knowledge retention when you're in that crucial calibration phase. We've got the body peg system, the draw to learn challenge, and the Feynman simulation. Let's break each of these down really quick so you can add them to your toolkit.
First up is the body peg system. This technique involves anchoring new information to familiar body parts through vivid mental imagery to construct a mental model map. Going back to Captain Spark, if he keeps messing up 6 times 7, he might imagine 6 giant number 7s doing a wild dance on his left shoulder. By pegging that tricky fact to a physical location on his body with a bizarre, memorable visual, it locks into his brain significantly faster than just staring at a textbook.
Next is the Draw to Learn challenge. This tool is all about encouraging active visual learning by sketching out complex concepts. Next time you hit a wall in your log, try grabbing a blank piece of paper and literally drawing the problem out. And hey, you don't need to be an artist here. The physical act of sketching just forces your brain to actively process the information, organize it visually, and expose any missing links in your logic.
The final tool is the Feynman simulation. This one requires you to simplify and explain concepts to identify your own knowledge gaps. Basically, you just act as the teacher. Try explaining the topic out loud to an invisible classroom as simply as humanly possible. If you start stumbling over your words or using complicated jargon to hide what you don't really know, boom, you've just uncovered the exact missing pieces in your own understanding.
We've covered a ton of ground in this explainer today, from the high-level data of Carnegie Mellon all the way to the daily calibration habits of our learning detective. So I want to leave you with this final thought. What will you calibrate in your learning journey today? I challenge you to take out your own detective magnifying glass, grab a notepad, and immediately apply this framework. Make a prediction, test it, and calibrate to something you are practicing this very week. Keep questioning, keep iterating, and we'll see you on the next explainer.